Hey, it's Coach Reeves. Today I'm going to show you how to solve exponential equations that have the same base. Okay? So when we look at this example, my base is a 5, the exponent is an x, the exponent is a 3. When we're in a position when the bases are the same, then I can set up an equation using their exponents. In this situation, I can tell you that x equals 3. Because think about this. If this was a 3, then those would be exactly the same. Over here, I have the same base. But now, look at my exponents. I'm still allowed to set up an equation. So I can say that x minus 2 equals 4. Add 2, x equals 6. And think about this. What is 6 minus 2? 4. And they would be the same. 3 to the 4th, 3 to the 4th. Okay? All right. We're going to keep getting a little more difficult as we go. Now I don't have the same base. I need to see if I can rewrite 16 as an exponent. Does anybody know how to rewrite 16 with the exponent as 4 as your base? Sure. You could convert 16 to 4 to the second power. There's 16. Now my bases are the same. So I can set up my equation and I can say that, let's use the exponents, x plus 1 equals 2. Minus 1, x equals 1. So if you go back and substitute it, 1 plus 1 is 2. And that gives you 4 to the second power, and that's 4 to the second power. Okay, let's keep moving. All right, so we picked this problem to show you, or to remind you, that when you multiply, you add the exponents. Okay? So, I still need to get the same base. All right? I'm not sure what 16 is. Okay? So, I'm going to go to my calculator real quick to show you how to do this with your calculator. But so, we're going to go to the calculator. Let me get a new document. All right, let's get a blank. We're going to go to calculator, and we're going to say menu, number, factor, and we're going to put in 16. And look at my prime factorization. Yay! 2 is my base, 4 is my exponent. Okay? So we have here 16 can be written as 2 to the 4th power. Let's bring this down. I have 2 to the x power times 2 to the 3x power. Now all the bases are the same. But remember what I said, that when we multiply, you add your exponents. So we're going to ask you to go x plus 3x equals 4. Got it? X plus 3x, this is going to give you 4x equals 4. You divide by 4. And you're going to get x equals 1. Now, if you want to plug it back in to check it, you can check it. But 2 to the first power, 2 to the first power is 2. Times 1, 2 to the third power is 8. And 2 times 8 is 16. So my answer here would be 1. Yes, it checks. Okay? All right, let's go to another problem. Don't panic. Don't panic, okay? Look at this. 2 is my base. 2 is the base. So we're going to take this in small little bites, okay? I need to see if I can rewrite the number 4 with a base of 2. And sure, you're going to come in here and say, yes, coach, 2 to the second power. 2 to the second power, that's the same thing as 4. But what we remember from the other worksheets is when I have a fraction bar, let me do this. when I have this fraction bar and I push this to the other side of the fraction bar, it changes from an exponent with a positive 2 to a negative 2. So when this pushes up, this becomes 2 to the negative 2. Hopefully you remember that from the last worksheet. Okay? And then 32. I'm not sure about 32, so I'm going back to the calculator. So I'm going to say menu, and we're going to go number, factor. I'm going to put in 32, and it turns out that this is 2 to the 5th power. Yay! It's still 2 as my base. So we're here. We're going to rewrite this as 2 to the 5th power. Let's look at what we have. I have 2 to the negative 2 times 2 to the x equals 2 to the 5th power. Remember, we changed this to 2 to the 2nd, but when I crossed the fraction bar, it became negative. This is still the same, and we converted 32 to 2 to the 5th. Now we can set up an equation. Now I can set up negative 2. Let's move this just a little bit. I can set this up as negative 2 plus x, because when we multiply, we add the exponents, equals 5. Plus 2, x equals 7. So take it small bites at a time, and you're going to be fine. Okay? Let's keep going. All right, the number gets a little bit bigger. And it's a head scratcher. I have no idea what my base is. So what am I going to do? I'm going to pick the smaller number, and I'm going to see what I can do with that. I'm going to try to convert that. I'm going to go to my calculator. All right, 27. So here we go. Menu, number, factor, 27. Enter. So 27 is 3 to the 3rd. Okay? Some of you may already know that, but that's okay. So we're going to come back here, and I know that 27 has an exponent. All I'm going to ask you to do is focus on the 27. 27 can be written as 3 to the 3rd power. That's the same as 27. But my 27 has to be raised to the negative b. Correct? Okay? That's 27 raised to the negative b. Over here, I have 243, and it is raised. It has an exponent of b plus 2. So I'm going to try to figure out if I know how to write 243. So we're going to go menu, number, factor, 243, and I hit enter, and it turns out that it's 3 to the 5th power. So back to the worksheet, 243 is 3 to the 5th power. That's equal, that's the equivalent of 243. So I take my 243 and I have to raise it to the b plus 2. Quick reminder, remember when we had this on a worksheet and I did this and I had x to the 2nd power and we raised it to the 3rd power. We ask you in this situation to multiply. So when you go power to power or raise the power, you multiply and that would give you x to the 6th. Same concept right here. I am raising the power, but I'm going to have to multiply. So I'm going to ask you to go 5 times b plus 2. On this side, I'm going to ask you to raise the power or go power to power and multiply and say 3 times negative b. Do you understand what we're doing? Okay? We distribute, and I get 5 times b is 5b. I distribute, and I get 5 times 2 is 10. Equals, And when I multiply, I get a negative 3b. All right, let's bring this down so you can see it a little bit better. I'm going to move the 5b. I'm going to go minus 5b, minus 5b. This will cancel. 10 equals negative 8b. We divide by negative 8. We divide by negative 8. This cancels. And I reduce. And I get b equals a negative 5 over 4. Again, what was the whole point about this? Raising the power, power to power, we got to multiply. Okay? All right, see where we are. Let's try one more. Don't panic. Don't panic. You've already done this. Look what you've done already with the calculator. You have already told me that 32 is 2 to the 5th power. 32 is going to be 2 to the 5th power. So in our problem, I have 32. I want you to write this as 2 to the 5th power. Here's my 32. I want you to write 32 as 2 to the 5th power. But this is 64. What are we going to do with 64? Not sure. So I'm going to go to my calculator. I'm going to go menu, number, factor. 64 is new. So I'm going to say 64, enter. That's going to give me 2 to the 6th power. 2 to the 6th. So we're going to ask you to treat 64 as 2 to the 6th power. But look what we have. We have to raise the power. We have to raise the power. So what I have is I have 2 to the 5th over 2 to the 6th, but we're raising it to the negative 3x. I have to multiply. I'm going to get 2, 6 times negative 3x is a negative 18x equals, I have 2 to the 5th, but I have to raise the power, and that's going to give me 5 times 3x is 15x. All right. 2 is my base, 2 is my base, 2 is my base. That's a good sign. But we don't need this in the denominator. I'm going to push this up. I'm going to push this up to the numerator, and when this crosses the fraction bar, this turns into 2 to the positive 18x. Remember, when we cross the fraction bar, my exponent will change from a negative to a positive or a positive to a negative. In this case, it's going to turn into a positive 18x. Okay? So look what we have now. What do we do when we multiply? Well, when we multiply, we add our exponents. So we're going to say 5 plus 18x equals 15x. You see how we got that? Moved it up. Let's undo that real quick. We moved it up and became an 18x. We added them and got 15x. We're going to go minus 18x minus 18x. 5 equals a negative 3x. We divide by negative 3. And we're going to find out that x equals a negative 5 over 3. Okay, I got one more to do. One more problem. See if we can get you taken care of. That's a lot of zeros. Okay? But can you write that? Sure. Because you have done what? You have done scientific notation. You probably converted this stuff a while back. We're going to treat this. I've got 1 million, which is 1, 2, 3, 4, 5, 6 zeros. 6 zeros. So we're going to change this to 10. There's my number. 10 to the what? 1, 2, 3, 6. That's 10 to the 6th. That is the same as 1 million. But it has an exponent of negative 2k. So we have to raise this to the negative 2k. Times. We're going to write 1,000. We're going to change this to 10. And we have 1, 2, 3 zeros, so that's 10 to the third power. Raised to the negative 2k. What do we do with the 1? Here's the trick. All right? I don't know if you'll remember this, but when I write this, you're going to go, oh, I didn't think about that. Anything to the 0 power is the number 1. So what if I did this? 10 to the 0 power. 10 to the 0 power is equal to 1. But now look, the bases all match, don't they? So when you're working a problem like this and they put it equal to 1, keep your base the same and just give yourself an exponent of 0, because any number to the 0 power is going to get you a 1. Okay? All right, now look, we're multiplying. We're multiplying, so what are we going to do? We're going to add our exponents. We're going to say negative 2k plus negative 2k, negative 2k equals 0. A negative 2 and a negative 2 is a negative 4k equals 0. You divide by negative 4, and it just turns out that k equals 0. All right, so as we went through this process, things got a little more complex, okay? So let's backtrack to remind you what you just did. So we're going to go back to the beginning. We said that we needed to have the bases the same so we could set up an equation with the exponents. We said sometimes I may have to change and rewrite this as an exponent so the bases will match. And then we kept going, and they said, okay, remember that when we multiply, we're supposed to add the exponents. And then we said, if I had a number that was in the denominator, and I pushed it up, the exponent goes from a positive to a negative or a negative to a positive. We then said that if you have to raise the power, you have to multiply. And then we said the same thing. If you have to raise the power, you're going to be good. The big next thing is right here. If you get an answer of a 1, you can write it as your base to the 0 power. Now look, I know some of this might be confusing, but the only way you're going to be able to do this is try it. All right? And if you do make a mistake, then ask questions and give us a chance to help you. Okay? Either email us or show up in a Zoom and let us know where we need to help you. But we can't fix it if we don't know what's wrong. All right. Hey, good luck. All right. We'll be here for you.